So while I'm speaking about gene editing in general, my focus will be CRISPR-Cas9, and we haven't really given an overview of the science. I don't have the time to do that, but I'll use the metaphor that everybody uses. Think of word processing. Think of the cut and paste tool that you have in the word processor that you use. So this is a natural mechanism that allows you to actually replace pieces of DNA with other pieces that you wish to introduce in a way that is cheaper than any way we've had before, safer, more effective, and more precise. And I want to start with the notion of hype, which means an overall exaggeration of benefits and promises that, as Eric pointed out, we've experienced over and over again with gene therapy, with stem cells, with cloning. Each time, this is the next big thing. This is going to revolutionize medicine. We will never look back. We heard these things over and over again, and then reality hit the ground, and we realized the limitations of the technology, the uncertainty of the technology. We're sort of living this now regarding CRISPR-Cas9. It's, as I just said it, it's safer than everything we've ever had. It's cheaper, it's more effective. And then what happens, this kind of hype creates a polarized debate. Because while we exaggerate the benefits, this will allow us not only to cure all babies, but to prevent and eradicate the most serious diseases. We also tend to potentially exaggerate the risks. So we talk, this can be transmitted to future generations. This will impact, as a result, millions of human beings. This will change the course of human evolution. So these kinds of, I don't want to use the word exaggeration, but this kind of intensity on both sides of the debate regarding the benefits and regarding the risks leads to a polarized atmosphere or discourse that makes governance challenges even more difficult to resolve. So recently, Jennifer Doudna gave a TED Talk that she titled, "We Can Now Edit Our DNA, but Let's Do It Wisely," and of course we can all agree to that. Interestingly, the two inventors, discoverer of CRISPR-Cas9 are both women, Jennifer in the US and Emmanuelle Carpentier in France. And I think this technology has Nobel Prize written all over it. It's just a matter of time. So this will be nice. Maybe we'll have those Nobel Prize winners while we have an American female president. That would be very exciting times. So what I'd like to do in the few minutes I have is give a very, very high-level overview of the governance initiatives that are currently taking place around the world in relation to gene editing. And I'll start with some basic distinctions that these policy initiatives are based on. So first of all, between using the technology in plants, animals versus humans. And the focus where we feel there's the most challenge is in the area of applying it to humans, because some of these initiatives have said, look, with plants and animals, it allows us to do more accurately and more effectively what we have been doing, but we're not really identifying any novel risk. And we believe overall that our current regulatory frameworks can deal with the risk assessment and with the evaluation of using a new technology in these areas. Again, very high level. I'm not getting into details, but we can get into them in the discussion. Another distinction is between research, in embryos, research on somatic cells versus germline cells. So are we going to do this cut and paste procedure in the cells of an adult human being, which means it might cure, it might do harm, but it will not pass on to that individual's children? Or are we going to allow ourselves to do this in sperm, egg, or embryos in a way that will be transmitted to future generations? And of course, the implications are on a totally different scale, as well as the issue of consent. You know, when you're a participant in a novel research, you take risks, you consent to these risks, but we cannot get consent from a person that we're currently creating without knowing what risks we're imposing on that generation that we're creating. And the third one is treatment versus enhancement. If we are ever to edit human embryos or human gametes, are we doing this in order to eliminate serious diseases? mild conditions, or are we willing to venture into the area of human enhancement and use this technology to create better human beings? And as you see, I'm layering it in this way because it becomes more and more ethically, socially, politically controversial as we go down these distinctions. Here I'll go quickly. There are preclinical studies, and then you move to the clinical stage. How will we know that we're ready to move on to the clinical stage? What level of evidence is sufficient? Of course, this is a question that we ask about every kind of study, but if we believe that the implications here are more long-term, more severe, this becomes a big question. Are we going to do research on embryos that we do not plan to implant? We do not plan pregnancy to occur. Do they have to be non-viable, or can we do them as the UK just authorized on healthy human embryos that potentially could be implanted? And at what point are we going to start actually editing embryos and doing the first trials that actually involve pregnancy and the creation of new human beings? Maybe never, maybe sooner than we think, but there is currently a global consensus that we're not ready to cross that line. Any group in any country that sat together to think about the current governance of gene editing agreed that we are not there yet. A quick chronology of international recent events, and you see this is starting about a year ago, so it's all very, very new. The Society of Stem Cell Research suggested a moratorium on the clinical application of germline editing. Then a report came out that Chinese researchers edited non-viable human embryos. So again, there was a reaction of governance initiatives in relation to this advance. Then the NIH decided not to fund gene editing in human embryos. When the NIH makes these decisions, it trickles to other places. In June 15, the US Congress held a hearing to review the science and ethical implications. A lot of our colleagues had an opportunity to express their views. And then a year ago, the Hingston Group, a global network of researchers, bioethicists, and policy experts, issued this consensus statement that said we do need to use this technology to do research on human embryos, but it's not sufficiently developed to consider human genome editing for clinical reproductive purposes. One example of that line in the sand that we're currently all seem to be comfortable drawing. And then, of course, in December, the very mediatized, Twittered, and heard of International Summit on Human Gene Editing in Washington, D.C. to explore the scientific, ethical, and policy issues, followed by the first approval of a study on viable human embryos using gene editing in the UK this year. And even more recently, a second Chinese team publishes results of using CRISPR to introduce HIV-resistant mutation into embryos, but they admit in the publication that a lot of safety issues remain. So this is sort of a quick chronology of policy and advances. Key points from this DC summit. First of all, clinical use in somatic cell. They actually issued a statement, the organizing committee issued a statement that surprised some people in how permissive it was. Because they not only said this kind of research should be allowed, they said it should be encouraged and funded. Many of the most promising applications regard somatic cells, editing out mutations that cause diseases, improving the ability of immune cells to target cancer, etc. And the conclusion was that existing and evolving regulatory framework can appropriately evaluate this use. However, as I said, regarding germline editing, a lot of issues were raised. I'm only highlighting the difficulty of predicting harmful effects, off-target editing, for example, intending to do one thing, ending up doing another, the impact on future generations, the idea that by using it for enhancement, we will exacerbate inequalities, or even if we use it for therapies, it might be very expensive at first and only certain people will have access to it. And finally, this notion that we're somehow tinkering with human evolution, playing God, then you get into the theological arguments, and this is where it becomes really polarized. Bottom line, would be irresponsible to proceed with any clinical use of germline editing at this time. And going forward, they highlighted over and over again the importance of creating an international forum to engage in a debate and of public engagement. Now, everybody likes saying public engagement. How to do it well is one of the greatest challenges we have. It's an entire area of research for people like us. How to consult with the public effectively. It's extremely costly. It usually doesn't provide the outcomes that we wanted. Major challenge. Here in Canada, what's at stake? We have a federal act that does not allow us to do any of this. So we're not allowed to touch, we're not allowed to alter the genome of a cell or a human being or an in vitro embryo such that the alteration is capable of being transmitted to descendants. So our law doesn't say don't transmit it, it said don't do it if it's capable of being transmitted. And that means that even some of the uses that, for example, the DC Summit were encouraged, we cannot perform such research right now in Canada. Does that mean that we should revisit our current policy, our current laws? Should we modify the Act in order to allow research on viable or non-viable embryos, in order to, for example, ensure Canadians access to cutting-edge treatments, to promote Canada's competitiveness in this area of research on the international scene, to show that Canada respects scientific freedom and only uses the right level of regulation to address the current risk? We recently held, the Stem Cell Network organized a workshop that Eric participated in, and we discussed these issues. How should Canada go forward on this issue? And we are ready to publish our recommendations, our conclusions, which basically say, yes, we should revisit our policy because we are using policy tools that are right now possibly inappropriate for the level of risk that is on the table, but especially for what we stand to gain if we allow research, not for reproductive use, but research. So this is just a teaser for publication that we have coming up soon on this topic. And I want to end with another aspect of what's at stake, and that is how do we address biohacking or do-it-yourself gene editing? If you type CRISPR-Cas9 into Google, one of the first things that will come up is kits for sale, and they're not very expensive. And anybody with, I'm told, anybody with basic training in biology can use them. Who would it be? China? The 400-pound guy? I don't know who it's going to be. But it's something that we need to consider as we go forward. Thank you.